Do you know what will be the square of any real number? Yes, you should know that square of any real number is always positive. Friends, let's see this example. X square plus 1 is equal to 0. So can you determine the value of x here? Here we can write this x square is equal to minus 1. Now here we see that square of any number, suppose here x, it has become negative. That means this equation has no real solution. In order to provide the solution of such equation, the number system is extended and has given birth to complex number system. In a complex number, root under minus 1 exists, which does not exist in the real number system. And this square root under minus 1, we denote it by iota. This is just the imaginary concept to give the solution for this variable x. Friends, it is believed that the concept of complex number is developed by a Danish-Norwegian mathematician, Caspar Wessel. And you should know that complex number is the superset of real number. That means natural number is inside, integer is inside, rational number is inside, real number is inside, complex number. In this way, the number system goes. So if you try to search for the solution of this equation, then it is x square equals to, we write instead of minus 1 is I square, and then the value of x is equal to plus minus I. Here plus minus I is known as imaginary number. Okay, so if you define a complex number, then an ordered pair a comma b of two real numbers a and b is called a complex number. A complex number is generally denoted by z. In some countries we say it as z or w, and we denote the set of complex numbers by double stroke c. It is to be noted that a comma b, the ordered pair a comma b, can also be written as algebraic expression form as a plus ib, where a is at real part of complex number and b is at imaginary part. Remember, a and b are the two real numbers, and real part and imaginary part are their positions. If we see the geometrical representation of complex number, then this complex number a comma b, where it has two components, x component and y component. So this x component a, we take it as real part of z, and the y component of this complex number, we take it as imaginary part of z. Okay, here the x-axis is called real axis and y-axis is called imaginary axis of complex number. Now let's see the integral powers of I. You should notice that I to the power 0 is equal to 1, I to the power 1 equals to I itself, I square equals to minus 1 as you have seen earlier. Then what will be the value of I cube? You can write this I square into I, so it is minus 1 into I, that is minus I. Similarly, I to the power 4, can you say? You can write this I square whole square, that is minus 1 whole square, that is equal to 1, and so on. We can find the values of powers of I. In general, we can write I to the power 4n if it is there. That means the power of I is multiple of 4, where n is an integer. Then I to the power 4n is always equal to 1. I to the power 4n plus 1 equals to I to the power 4n plus 2 equals to minus 1, and I to the power 4n plus 3 equals to minus I. These all proofs are very simple, so I have not done here. You can prove it by taking few examples yourself also. As a whole, any integral power of I, its value circulates between 1, minus 1, I and minus I. Except these other values not possible. One thing you note it that for any two real numbers a and b, root under a into root under b will be true only when both are positive, or at least one of them, either a or b, is non-negative. If both are negative, then like this cannot be written. I mean, root under minus a into root under minus b, you cannot write like this, whole root under minus a into minus b is equal to root under ab. This is absolutely blunder will be there. For example, root under minus 1 into root under minus 16, you cannot write it as whole root under minus 1 into minus 16 and then is equal to root under 16 is equal to 4. This is wrong. In fact, this you have to do like this: minus 1 into root under minus 16 equals to I into 4i, that is 4i square, that is equal to minus 4. Okay, this is correct. If somebody is trying to fool you by doing this as minus 1 equal to I square equal to I into I, that is equal to root under minus 1 into root under minus 1 is equal to whole root under minus minus plus 1, that is 1. That means he has proved minus 1 equals to 1. I think now you can say it is not correct. Okay, so if two complex number z1 and z2 we denote it as a plus ib and c plus id, then can you say z1 plus z2 will be how much? I think this you should know. It will be a plus c plus ib plus d. Real part with real part, imaginary part with imaginary part. Similarly, z1 minus z2, you find it and check your answer. So as of multiplication and division also, I think you can get the answer. We have got the conjugate of a complex number also. If z equals to a plus ib is a complex number, then its conjugate is given by z bar equals to a minus ib. Okay, geometrical representation of a conjugate of a complex number is shown in the figure alongside, where z equals to a plus ib is a complex number, then its conjugate is denoted by a minus ib. Okay, now let's see the modulus of a complex number. The modulus of a complex number denoted by z equals to a plus ib is denoted by this symbol, where modulus of z is equal to root under a square plus b square, that is square root under square of real part plus square of imaginary part. Okay, so what is this modulus of z gives? It gives the distance of complex number from origin. Geometrically, you can see here, where x component is a and y component is b, that is real part and imaginary part, then distance from origin is given by OP, as you can see in the figure here. So I hope about modulus of complex number you have understood some of the basic concepts. So this was the basic concept regarding the complex number, friends. I hope you have understood. So if you like the video or not, you please mention in the comment box. Thank you very much.